This job aid was produced by the National Weather Service Training Center to assist qualified NWS, DoD, and FAA electronic technicians in performing routine maintenance. This presentation will reference maintenance procedures in Engineering Handbook 6-513 Revision 2, dated 25 June 2020. The technician will refer to the most recent Engineering Handbook for current procedures, cautions, and warnings. Prior to calibration, all online checks must be performed to verify the transmitter and receiver are working properly and that the IFDR is configured correctly. Values captured in this video are from a non-operational site and will not be the same as at a field site. Do not use them to judge measurements at your site. If you want numbers to compare your measurements to, use previous measurements from your site. Paragraph 6.6.3.3.7 AME CW Test Signal Measurement. This procedure calculates adaptation data values for the AME Test Signal Power R34 horizontal and R33 vertical. If no hardware was replaced, these measurements should be very close to the previous values recorded in adapt.cur.dat and Table 6-14. To aid in mathematical calculation and recording of measurements performed in this procedure, consider opening the System Test Software offline calibration chart. If you use the offline calibration chart, it is a good practice to record the measurements on paper as insurance against data loss. This procedure requires a calibrated power meter, a 20-foot power sensor cable, medium power sensor, a Type N female bullet adapter, and a Type N male 2QN female adapter. Fault Note 69, steps 1 through 21 should be completed, and the antenna should be stowed at 23 degrees and a ladder or scaffold positioned to access 2A5 DC 2 and 3. Disconnect cable 2W575 from horizontal 30 dB coupler 2A5 DC 3 J1 by releasing the QN male connector. Then connect the test equipment to cable 2W575. In the System Test Software window, click Control, AME Receiver Control. Configure the following options: Test Source to AME Test Signal, Step Attenuator Attenuation to 0, Byte Cal Control to ZDR Test, HV Bias Control to H to both. Click Inject Signal. Allow the power head to warm up until the measurement stabilizes for at least 45 seconds. Should be within plus or minus 0.02 dB. A typical medium power sensor takes 2 to 3 minutes to warm up. Measured power should be between 10 to 13 dB. If the power level is outside this range, recheck connections, verify power meter settings, power sensor calibration, and the settings in the AME receiver control window. If the meter does not settle to within plus or minus 0.02 dB, it may be necessary to try another sensor. Click Inject Signal again. The system will cycle the signal off and back on. Wait about 15 seconds and record the power meter reading. Do this 2 more times. If all 3 samples do not fall within 0.02 dB of the average reading, continue taking measurements until the power sensor warms up and 3 consecutive good measurements are made. If the expected test result is not met, replace the QN male adapter on the cable. If that does not resolve the issue, perform Fault Note 82. If Fault Note 82 passes and the ETR is still not met, replace cable 2W575. In the AME receiver control window, select None for test source and click Inject Signal. Disconnect cable 2W575 from the test equipment and reconnect it to the horizontal 30 dB coupler 2A5 DC3J1. Disconnect cable 2W574 from vertical 30 dB coupler 2A5 DC2J1 and connect the test equipment to the cable. Back in the AME receiver control window, set test source to AME test signal. Step attenuator attenuation to 0. Byte cal control to ZDR test. HV bias control to H to both. Click Inject Signal. As before, allow the power meter to warm up until it remains steady for at least 45 seconds. Click Inject Signal again, wait 15 seconds, and record the power meter reading. Measured power should be between 10 to 13 dB. If the power level is outside this range, recheck the test equipment connections and verify the settings in the AME receiver control window. Click Inject Signal and record the meter reading 2 more times. If all 3 samples do not fall within 0.02 dB of the average reading, continue taking measurements until the power sensor warms up and good measurements are made. If the expected test result is not met, replace the QN male adapter on the cable. If that does not resolve the issue, perform fault node 82. If fault node 82 passes and the expected test result is still not met, replace cable 2W574. When finished, select None for the test source and click Inject Signal and close. Remove the test equipment from cable 2W574 and reconnect cable 2W574 to the vertical 30 dB coupler 2A5 DC2J1. If you use the offline calibration chart, enter your data if you have not already done so. Update adaptation data in adaptcur.dat. If you are performing additional calibrations, do not restart the RDASC at this time. If no further calibrations are being performed, shut down the RDA laptop and restore the radome to operating conditions in accordance with fault note 69, steps 22 to 35.